Okay, super hoping that your Khan Academy will match mine. So if it's helpful for you to say that, to write down Euler's formula that every y is going to equal the y that came before plus step size times the derivative that came before. I just keep saying it like that in my head because it helps me just go through the problem. It's just like when I have quotient rule and I say ho-de hi minus hi-de ho over ho-ho or whatever. I just have that like mantra in my head so I don't screw it up. So again, hopefully your Khan Academy matches mine, otherwise this is a complete waste of time. So my first one says dy dx equals x minus y. Find up to f of 3 equals 1. They want me to find f of 6 with use Euler's method with 2 steps of equal size to get to f of 6. So what is our step size going to have to be? It can't be 1 because then I would go to 4 and the 5. My step size is going to have to be 1.5 because they only want 2 steps of equal size. Okay, so I'm going to have the x that I start at is 3. The y that I start at is 1. The y prime that I start at is x minus y, 2. There's step 1. Our next x, let's add 1.5 to this, so 4.5. And our next y, we use Euler's method. To find the next y, we use the y that came before plus the step size times the y prime that came before. So I'm going to get 4. The y prime is going to be always going back up to the formula they give us, x minus y. 4.5 minus 4 is 1/2. Okay, there's the first step. Second step, add 1.5. So our next x will be 4.5 plus 1.5, so 6, which is where we're going to want to end. And our next y, I need to use Euler's method. Use the y that came before plus the step size times the derivative that came before. So we're going to have 4 plus 2, 6. Let's see if we're right. I hope that we're going to hear the magic little put in 6. Try again. Shoot. Oh, God. Oh, my gosh. What did I do wrong? The y that came before plus the step size times the derivative that came before. Ah, dang it. Sorry. I'm not redoing this movie. I don't care. I mean, I care, but I'm not redoing it. 4 plus, this is, I added them, 3/4. So 4 3/4, 4.75, whatever. Hopefully you already knew I was wrong and you just were yelling at the screen. Okay, next question for me is a table. So this looks really different than what we've done before. So for the table, we are given that f of 0.5 equals 0. The step size is 0.5. And we're trying to find f of 2.5. So we're going to start like we always do. So the first x is 0.5. The first y is 0. And the first derivative, how do we find that? We go to our table. This table is telling us derivatives. So I would go to my table and I'm looking to see, okay, the x is 0.5, so go to my table. X is 0.5, the derivative that goes with that is 3. So I don't have a formula to look back at for this one, but it's okay. I have a table. It's actually easier. I don't have to compute anything. It's telling me the derivative there is 3. So there's step number 1. Step size is 0.5. So my next x is 1. My next y, I need Euler's method. So Euler's method, take the y that came before plus the step size times the y prime. So I'm multiplying, so I'm going to get 1.5. The derivative, derivative. Again, I'm going to look at the table. What am I looking for? The table only gives me x values, so I'm looking, when the x is 1, what's the derivative? So look over at my table. When x is 1, the derivative is 2. So the derivative is 2. Keep going. So obviously this requires a bunch of steps. I got to get all the way to 2.5. So my next x is 1.5. My next y is 1.5 plus a half times the step that came before, or the derivative that came before. So we got 1.5 plus 1, so this is 2.5. I'm sure I'm going to make a mistake here, I'm just telling you right now. So the derivative when x is 1.5 is negative 1. Next step. Next x is 2. Next y is 2.5 plus 0.5 times negative 1. So 2.5 minus 0.5, so 2. And my next derivative, go to the chart, is negative 2. Last step, x is 2.5. Y is the y that came before plus 1/2 times the derivative that came before. So 2 minus 1 is 1. For the love of God, be correct. Yay. My dog. Okay, number 3. dy dx equals x plus 2y minus 1, and y of negative 1 equals k. Ooh, getting fancy. Whoops. Using Euler's method, starting at x equals negative 1 with a step size of 1 gives the approximation that y of 1 is 11. So they're telling us the end. All right, let's see. I haven't done a problem like this, and I don't even know if I have. So let's see if we start. So x sub 0 is negative 1. Y sub 0 is k. And y prime sub 0 is, so the derivative is here, and it's going to be x plus 2y minus 1. So that's going to be negative 1 plus 2 times y minus 1. So that derivative for us is going to be negative 2 plus 2k. Okay, let's see what that does. So my next line, if the step size is 1, whoops, sorry, off the chart here. If the step size is 1, my next, and what am I trying to get to? I'm trying to get to an x of 1. So my step size is 1, so my next x is going to be 0. My next y is going to be, using Euler's formula, the y that came before plus the step size times the derivative that came before. So I'm going to get 3k minus 2. And the derivative is going to be x plus 2y minus 1. So x is 0 plus 2 times y minus 1. So 6k minus 4 minus 1, so 6k minus 5. All right. Then my next step, which should be my last, is my x is 1, and my y is the y that came before plus the step size times the y prime that came before. So I'm going to have 9k minus 7. And they told me that this should have yielded a result of 11. So they're telling me that when you use Euler's formula and you get to the point where x is 1, this y should be 11. So this should turn out to be 11. So what does k need to be? Well, let's solve this. So k would be 2. It's a cool little problem. All right, last one, they have the table for me that they want you to fill out. Okay, dy dx is x plus y, y of 1 equals 2, step size is 0.2, and we're trying to get to 1.6 on the x. So they're going to want us to fill out this table. n, x sub n, y sub n. They start with 0, 1, 2, 1, 1.2. Okay, so what is n? N's just telling us like what step we're on. This has no relevance whatsoever. 1, 2, 3. They just want us to go through a couple of steps. I would love to see a derivative column over here because then it's set up the way I normally set things up. So this is just having you look at it a little bit differently. And they don't require you to put any y prime in, but you're going to need to find y prime to continue along the chart. So boom, boom, we're going to need to find that derivative. So the derivative by finding x plus y, so that's 3. So now our next step, we add 0.2. So what's our next y? Our next y is the y that came before plus the step size times the derivative. So 2 plus 0.6, so we got 2.6. The chart doesn't require the derivative, but we're going to need it. So the derivative is found by doing x plus y, so 1.2 plus 2.6. So this is going to be 3.8. The next x is 1.4. Add the step size to it. The next y is the y that came before plus the step size times the derivative that came before. Oh gosh, 2.6 plus, oh, do I have a calculator in hand? No, I don't. I know that this, like my brain, seriously, I just can't. 0.76. So this is going to be, and 2.66. 3.36? I don't know, maybe. It'll probably tell me I'm wrong. The y is going to be these two added up, so 4.76. Let's see if we're right. Let's do it one more time. 1.6. So this y, the y that came before, plus the step size times the x that came before, or times the derivative that came before. You could probably use a scientific calculator for this. Like there's no other way. Your calculator can't do it for you anyway. I just don't feel like getting up to get it. So 4.76 times 0.2. 1, 2, 3. So I have 3.36 plus 0.952. I get that. Are we right? I don't know. Let's fill this out. So 1.2. Hopefully if you got what I got, then you can just turn it off. But I'm gonna go and just put all this in and see if we're right. Chances are, a mistake is somewhere. Yay. Okay, good job.